Hey guys, uh, what happens if we want to world in the space? Cold waiting got our board? A little story about it. To be able to weld to metal in the air, it is required to hit them beyond their melting point, but in the space it's a little different. How did it know? The astronaut Edwin conducted the first American spacewalk aboard Gemini 4. After returning to the spacecraft, the crane faced a problem. The watch would not close. NASA engineer at the time identified that the failure was due to a phenomenon known as cold welding. In space, if two metals come into contact, they can fuse without the need for heat, and this is due to the atomic structure of the metals. On Earth, the surface of the metal reacts with the oxygen in the atmosphere to create a protective layer of oxygen, and this prevents the two phase from coming uh, together. But in the space, this layer um, can weaken and reach a little force and impact. They can force together. Uh, Experiments in vacuum chambers and in space have to show that perfectly clean and metal surface when pressed in the uh, atom at atmospheric melt, but it unreally. The metals used in aircraft are never clean as they have rust, trace, and dirt. So after and the problem of the watch in Gemini 4 was not caused because when it was a straight door, but this does not mean it never happens. The Galilean spacecraft was heading for Jupiter, and while the scientists decided to deploy their Gitgain antenna that was supposed to open like an umbrella, it got struck. Three of the 18 legs of the antenna did not open because they were cold winding and the boss got struck. But cold winding is not all bad. Scientific had found it could useful in nanotechnology application because typical heat temperature, winding and scientific points and the nanoscale it's very difficult.
Hello everyone, I'm David and I'm going to talking about a topic that is what if we want to build in the space? Is it going to be good, bad? I don't know. Let's see. To be able to wheel here in the air, the two metals required to hit then beyond their middle point. But in the space is so different. How does it work? In the space, if two metals come into contact, they can fuse without the need for heat, and this is due to the atomic structure of these metals. Of the metals react with the oxygen in the atmosphere to create a protective layer of oxide, and this prevents the two pieces from coming together. but in the space, this layer can be weakened, and with a little impact and force, they can fuse together. Experiments in vacuum chambers and in space have shown that perfectly clean metal surface when they press in the ascent of the atmosphere melt. But in reality, the metals used in aircraft are never clean, as they have rust, grease, and dirt. Cool welding is not bad at all. Scientists found it quite useful in nanotechnology applications because typical high-temperature welding at specific points at nanoscale are very difficult.
To be able to metals in the air is required to hidden beyond their melting point, but in space it's a little different. How did it know? In space, if two metals come into contact, they can fuse without the need for heat, and this is due to the atomic structure of the metals. On Earth, the surface layer of the metals react with the oxygen in the atmosphere to create a protective layer of oxide, and this prevents the two pieces from coming together. But in space, this layer can weaken, and with a little force and impact, they can fuse together. Experiments in vacuum chambers and in space have shown that perfectly clean metal surfaces, when pressed in absence of atmosphere, melt, but in reality the metals used in the aircraft are never clean, as they have rust, grease, and dirt. In vacuum chambers has shown that perfectly clean metal surfaces, when pressed in absence of atmosphere, melt, but in reality the metals used in the aircraft are never clean, as they have rust, grease, and dirt. Cold welding is not all bad. Scientists have found it quite useful in nanotechnology applications because typical high temperature welding at a specific point in nanoscale is very difficult. Cold welding is not all bad. Scientists have found it quite useful in nanotechnology applications because typical high temperature welding at a specific point in nanoscale is very difficult.